Hello everyone, welcome to Pepcoding. I hope you all are fine and enjoying coding. So first of all, I want to meet you with my new friend, that is Mr. Camera. Mr. Camera also want to learn data structure from Pepcoding. So from now, Mr. Camera is also going to solve all the problems with us. So let us now start the today's problem. First of all, let me discuss what the problem is. The problem for today is to find the inverse of an array. In this problem, we are given a number n which represents the size of the array. Next, we are given n elements of that array and we have to calculate its inverse. So, to solve this problem, first of all, we have to know what the inverse of an array is. So, let's discuss. Let we take an example of an array of size, let's say 5. So, we have 5 elements. 1, 2, 3 and so Mr. Camera knows that the indexing of array starts with 0. I hope you all know this. So 0, 1, 2, 3 and 4. In this problem, we are having a constraint that we have to take the elements only in between the range of 0 to n minus 1, where n is the length of the array. Right, so in this problem, in this example, the length of the array is 5, so we can take the elements only in between the range of 0 to 4, right? So let's suppose 0 is present here, 1 here, 2 here, 3 here and 4 here, right? So now we have to calculate its inverse. Now the size of inverse is same as that of our original array, so the size of inverse will be 5, right? Now, in order to find the inverse, we have to replace the index value with the value of the element, right? So let's suppose 1 is present at position 0 in the original array. So in the inverse, 0 will be present at location 1. Next, 3 is present at location 1. So in the inverse, 1 will be present at location 3, right? Next, 0 is present at location 2. So 2 will be present at location 0. In the original array, 4 is present at location 3. So 3 will be present at location 4 in the inverse. 2 is present at location 4. So 4 will be present at the location 2 in the inverse. So this is our inverse, right? I hope you understand. Now let's try to find its solution. Now we can see that we have to traverse in the original array, right? So we are using a for loop to traverse in the original array. It will run from 0 to n minus 1, right? Where n is the length of the array dot length, right? So we are going to store the element in a variable name position, right? In the position we are storing the element present at the location, right? So in the inverse array, at that position, that is at this position, we are going to store the index. Index is stored in I, so we are going to store the index in the position. So I will get stored, that is 0 will get stored at the position. Position is what? Array of I. So 0 will get stored at position 1. 0 will get stored at position 1, right? So next I will be incremented to 1. So in the position variable 3 will get stored, and in the inverse at position 3 1 will get stored, right? At position 3 1 will get stored. right? So let's try to code this in the IDE. So we are providing with the original array and we have to code this function only, right? So we know that we have to take an inverse array of length. What would be its length? Yes, same as that of our original array, a dot length, right? Next we have to traverse in the original array. So for traversing, let's use the for loop from 0 to, right? So next we are taking a variable, say position, which will represent the position where the index will get stored in the inverse array. So what will be the position? That is the value present at ith location, ith index, right? Next, in the inverse array, at that position, we have to store the index, that is the location, right? So now the return type of this function is array. So let's return inverse in this, right? Simple. So let's try to run this. So we got the expected output. Let's try to submit it. So our code will get submitted. Let's take another example by using this. Let's take this code to our open board. So let's try this on the same example. Right. So first of all, we have created a new array of the same length, right? Like this. So we are traversing in the original array. So at position, in the position variable, 1 will get stored, right? In the position variable, 1 will get stored, and in the inverse, let's draw the inverse array. So in the inverse, at position, right? At position, at index 1, I will get stored. The value of I is 0. So at position 1, 0 will get stored, right? Next, position will get, I will get incremented to 1. In the position variable, array of 1, that is 3, will get stored. Now in the inverse array, at position, that is at 3, I will get stored, right? Next, the value of I will be incremented to 2. In the position variable, array of 2, that is 0, will get stored. And in the inverse, at position 0, I will get stored. 2 will get stored here, right? Next, I will increment it to 3. In the position variable, array of 3, that is 4, gets stored. And in the inverse, at position 4, I will get stored, that is 3. Similarly, next I will increment it to 4, and in the position variable, array of 4, that is 2, will get stored. Next, in the inverse array, at position, that is at 2, I will get stored, that is 4 will get stored. So we are getting the expected output, right? So if we talk about its complexity, then we know that the space complexity is, it's taking is n. Since we are using a new array, so it is taking a space complexity of, space complexity of big of n, since it's using a new array of size n, right? And time complexity is also big of n, since it's traversing a array of length n using the for loop, right? So it's using big of n space complexity and big of n time complexity, right? So I hope you enjoyed the problem, and Mr. Camera also got the solution, right? So thank you so much. We will meet in the next class.